Hello students, in this video we are going to see the detailed specification of model train controller, which is the continuation of the part 2. So here the detailed specification represents the more detail of the class diagram. So this class describing the analog physical object in the train controller system. So this figure shows the detailed specification of UML class diagram. The panel has three knobs: train number, then the inertia and the speed. It also has one button for emergency stop. We can change the train number setting and to reset the other control to the proper values for the train so that the previous train's control setting are not used to change the current train setting. To do this, knob must be provide a set knobs behavior that allows the reset of the system to modify the knob setting. Then the motor system. The motor system takes the commands into two parts, that is the sender part and the detector part. So these classes are relatively simple. They simply put out and pick up a bit respectively. Then the pulsar class. The pulsar class consists of a pulse width and direction of the motor. So the motor controlled by the pulse width modulation technique. Then we are going for the panel and motor interface classes. So the panel class defines the behavior for each of the controls on the panel. In panel class, new setting behavior uses the set knob behavior of the knobs. Then to change the knob setting whenever the train number setting is changed. The more interfaces defines the attribute for the speed that can be set by other classes. Then the transmitter class and receiver class. They provide the software interface to the physical devices that send and receive bits along the track. The transmitter provides a distinct behavior for each type of message that can be sent. It internally takes care of the formatting the messages. The receiver class provides a read command behavior to read messages off the track. Then the formatter class. The formatter class, as shown in figure, it holds the current control setting for all the train and repeatedly reads the panel and determines whether any setting have changed and send out the appropriate messages. Send command and is the utility function that serves as the interface to the transmitter that performs the basic action for the object. Then the panel active turns true whenever the panel value do not correspond to the value. So this is the description of the class, and this is the control input cases, which uses the soft panel to show current panel setting for the each of the train. So changing the train number must change the soft panel setting to reflect the current train speed and etc. This is a sequence diagram of transmitting the control input. So this consists of knob, spanner, formatter and transmitter. So for each change in speed, inertia, e-stop button, the knob should send the control setting to the panel. What the panel should do, the panel has to read the message from the knob and it will send the commands to the formatter. So formatters will responsible for converting the command into bit stream, and it will always check with whether the panel is active. Then it will send the command to the transmitter. Okay, the transmitter check with the speed, inertia, e-stop, and it will send the message to the receiver side. And whenever there is a change in train number, so the panel will set the set knob key so that the overall control box will reset its action. So after that, it will send the control setting to the panel knob. Similarly, there will be a receiver side sequence diagram. So the overall summary of this model train controller is, when we are going for UML diagram, that is interactive classes diagram, we can able to mention the detailed specification of each and every unit inside the console box as well as the receiver side, so that we can avoid the big mistakes. That is, the small mistake from the detailed description can be fixed by the time then and now, so that it can be easy to design a model train controller. Thank you.